Hello, grade 12 STEM students of astronauts, chemists, and virologists. I know this is already late, but don't worry, I am still giving an extension for the submission of your week 1 and week 2 long quizzes. So, after watching this video, please take note that the submission of your long quiz will be extended to March 29. That's Tuesday when you will be submitting your next module. I think that will be week 6 already. So for today's video, as I have already told you last time, this will be the explanation to your week 1 module on electric force and week 2 on electric potential and work. So we will dig into the mathematical calculations and sample problems with the formula. Okay, so I have noticed that as I look on your module on weeks 1 and 2, the long quizzes that were included were no longer part of the abstract part in your SSLM. So let's have a quick revision again of those weeks, and let's have another quiz, as I have said, for weeks 1 and 2. But for week 1, those who already have submitted, it's okay, but I am giving a different quiz for week 1 after you watch this video. Okay, so yeah, let's start. So your week 1 was about electric force, and this electric force is the attractive or repulsive interaction between any two charged particles. So you have already learned that a particle may be positively charged or negatively charged. Okay, so mathematically, the electric force may be computed by following this formula. This is K. This is a constant value of 9 times 10 raised to the 9th power. Okay, 9 times 10 to 9. The unit is Newton meter square per coulomb square. This is actually square. Newton meter square per coulomb square. And this is known as your Coulomb's constant. Then you have your Q1, Q2. These are your charge 1 and charge 2 divided by your R square, or the distance of separation. So meaning to say, if you have two charge, let's say this is charge 1, okay, and then you have another charge here, and then you have here Q2 for charge 2. So for example, these are both positive charge. Okay, so there is a force here between your Q1 and Q2. So the force here is the electric force, and the distance between your Q1 and Q2 is your distance of separation, and that's the R square. Okay, so let's have an example to that. So let's have a sample about electric force. So the problem is, what is the electric force between the two charges? This is positive 6 microcoulombs and negative 6 microcoulomb, separated by the distance of 6 millimeter. So we have to identify our given. So these are our charges, Q1 and Q2. Positive 6 microcoulomb is same as 6 by 10 to the negative 6 coulomb. Then your K constant, coulombs constant, 9 times 10 raised to 9 Newton meter square per coulomb square. Your distance of separation is 6 millimeter. So you have to convert this to meters, and that is 6 times 10 to the negative 3 meters. Okay, so our formula here is F K K Q1 Q2 over R square. Then 9 times 10 raised to 9 Newton meter square per column square. Column square, that's capital C. Q1 is positive 6. That's times 10 raised to 6 column and negative 6 times 10 to the negative 6 over R square. 6 by 10 negative 3 meter square. So, if you have your scientific calculators, that's 9 exponent 9 times 6 exponent negative 6 times 6 exponent negative 6 divided by 6 by 10 to the negative 3 the answer is 9,000 Newton or 9 by 10 raised to 3. Newton. Now, also included in your week 1 module is the electric field. So I noticed also in the long quiz, there were questions about electric field. However, it was not included in your SSLM. So I'm giving now the formula for electric field. Okay, so this is the formula. You have E equals F over Q for the charge. So this is your F. By the way, I forgot your unit for force, electric force. As discussed earlier, this is your electric force. The unit here is Newton or capital N. Okay, that's Newton. So meaning to say your unit for electric force per unit is F over Q. The unit will be Newton over, what's the unit for Q or charge? It's capital C or coulomb. Okay, so the unit will be Newton per coulomb. Now, if you're going to replace here your electric force dito sa formula na to, F will be replaced by K Q1 Q2 over R square. So you can actually cancel your Q here. So what is left is this formula. So meaning to say, you can also use this formula. Electric field is equal to KQ over R square, where K still is your Coulomb constant, which is, okay, there's the hirap naman ang pagsulat dito. K constant here is the 9 times 10 raised to 9. Ay, hindi ko masulat. Raised to 9, then Newton meter square per coulomb square. That's the unit for K. So medyo madilim na dito. Let's transfer here. This is the sample problem of the electric field. Problem. What is the electric field experienced by the test charge of 5 microcoulombs if the force on it is 30 Newton? So, our given the test charge of 5 microcoulomb, that is your Q. That's 5 times 10 raised to 6 coulomb. Your F is 30 Newton. Then your K constant is 9 times 10 raised to 9 Newton square per coulomb square. But remember, you will not use your constant here because our formula for electric field is F over Q. So your F is 30 Newton divided by 5 times 10 raised to negative 6 coulomb. The answer is 6 times 10 raised to 6. Unit is Newton per coulomb. So this is your answer. Okay, now when are we gonna use this K? Remember this formula, E equals F over Q. For example, we are going to replace here F with your KQ1 Q2 over R square rather, then all over the Q. So we only replace the value of F here with this formula, right? That's F over Q. So we will have K Q over R squared. So on other problems, we will be using this formula if we are not given directly with the force. For example, what the given are the distance of separation, the charge, and the coulomb's constant, which is already given. So kapag ang given lang ay Q and the R, then we can use this. And gamitin mo ang K. So dahil dito sa problem, wala naman given ang force at saka ang charge, F at Q. So ito lang ang ginamit natin. Okay?